Welcome back to Math with ACE. We are focusing on probability. We're focusing on independence and mutually exclusive and conditional probabilities right now. We are looking at the event G taking a math class, and the event H is taking a science class. G and H means that you're taking both a math and a science class, and we're given some probabilities. The probability of G is 0.6, the probability of H is 0.5, and the probability of G and H is 0.3. Are they independent? If they're independent, then one of the following has to be true. I'm going to show all three. The probability of G and H is calculated. The probability of G given H, is calculated by taking the probability of G and H and dividing that by the probability of H. G and H is 0.3 probability, and the probability of H is 0.5. That winds up being 0.6. The probability of G is 0.6, and because those are equal, yes, we have independence. So we verified it here. I'm going to continue to verify using the other methods as well. The probability of H given G is found by taking the probability of H and G over the probability of G. H and G is the same as G and H, even though the order is flopped. It doesn't matter. This is 0.3 divided by 0.6, which divides out to 0.5. Notice that the probability of H is 0.5. Those two are equal. I have independence, which we've already proven, but I'm showing again. Then, in order to calculate the last one, the probability of G and H is 0.3. That should be equal to 0.6 times 0.5, 6/10 times 3/10. That is 30 hundredths. That is the same. Excellent. Now, the note says you make the choice based on the information that you have. We have all of these given values, so any of the methods worked. It might be different depending on what you're given later. Okay. I showed these right above here. Okay. I'm going to go ahead and skip on to the next question. Example 327. Let the event C be taking an English class, D is taking a speech class. The probability of taking an English class is 75% or 0.75. Probability of taking a speech class, 30% or 0.3. The probability of taking an English class given you're in a speech class is 0.75. And the probability of taking an English class and a speech class is equal to 0.225 or 225 thousandths, depending on how you want to say your correct terminology. Justify your answers to the following questions numerically. Are C and D independent? In order for C and D to be independent, one of the three that we just did in a previous example needs to be true. I could say that they're independent if the probability of C given D is equal to the probability of D. And notice that I have C given D and I have D. So those are very easy to be able to compare. I don't need to do any other calculations, but the probability of C given D is 0.75 and the probability of D is 0.3. Those are not equal. So no, they are not independent. Are C and D mutually exclusive? If they're mutually exclusive, then the probability of C and D needs to equal 0. But the probability of C and D actually equals 0.225. So no, they are not. Then lastly, the probability of D given C. In order to calculate that, I would take the probability of D and C and divide that by the probability of C. D and C is the same thing as C and D. That's 0.225 divided by the probability of C of 0.75. which divides out to 0.3. So the probability of D given C is 0.3. Next question. We're dealing with boxes of cards. Red cards are marked with the numbers 1, 2, and 3. Blue cards are marked with the numbers 1, 2, 3, 4, and 5. The cards are well shuffled. You reach into the box and you draw one card. R is a red card, B is a blue card, E is even. So the sample space is red 1, red 2, red 3, blue 1, blue 2, blue 3, blue 4, and blue 5. So the total sample space has 8 outcomes since there were 3 red cards and 5 blue cards. Now we want to calculate the following probabilities. The probability of red is equal to how many red cards are there? There's 3. How many total outcomes were there? There were 8. So 3 out of 8. The probability of blue is then 5, because there's 5 blue cards out of 8 total. And the probability of red and blue, well, how many red blue cards are there? There's none. There's no green cards in there. There's no red blue cards. So the probability of that is 0, which means they are mutually exclusive. The probability of E is for even numbered cards. Well, if you look at your sample space, 2 is even, 2 is even, and 4 is even. That's 3 out of the total 8. We calculate the probability of even given you're in a B card, so given you're a blue card. We can do this one of 2 ways. You can do it using calculations, or you can do it looking at your sample space. So let's first calculate the probability of E and B, and then we'll divide that by the probability of B. So even and blue, looking at my blues, there's 1, 2 evens out of the 8 total in that sample space. And the blue cards we knew were 5 out of 8. Fraction multiplication, flip and multiply by the reciprocal, that is 2/5. But if we were to just look at the blue cards, we have blue 1, blue 2, blue 3, blue 4, and blue 5. That's 5 total outcomes in that sample space. And of those 5, only 2 are even, which is the same thing we got when we did the calculations using the total 2 in the formula. Let's approach the next one the same way. This is the probability of B and E over the probability of E. We know that B and E is 2 out of 8. And the probability of even, there were 3 out of 8. That's 2 eighths times 8 thirds, which is 2/3. And then again, if we consider just the even cards, that was R2, B2, and B4, 3 total. Of those 3, 2 were blue, which gets me the same value. Are the events R and B mutually exclusive? Well, yes, we answered that in A. R and B is red and blue. You can't be red and blue. I think it would have been a better question to say, are red and even mutually exclusive? No, they're not, because you can be red and even. Or blue and even mutually exclusive? No, they're not, because you can be blue and even. But this one is red and blue. Let G be a card with a number greater than 3, and let H be a blue card numbered between 1 and 4, inclusive. So G, let's list that out really quickly. G is a card with a number greater than 3. That is B4 and B5. Those are the only 2 outcomes there. And then H is a blue card numbered between 1 and 4. So blue 1, blue 2, blue 3, blue 4. And then I want to know if they're independent. Well, in order for them to be independent, we need to calculate some probabilities. You can do 3 different ways of calculating. You could say the probability of G given H is equal to the probability of G. You could calculate the probability of H given G is equal to the probability of H. Or you could say the probability of G and H is equal to the probability of G times the probability of H. Start with the first one. So the probability of G given H equals the probability of G. G given H, we need to calculate the probability of G and H and divide that by the probability of H. So H has 4 outcomes out of the 8 total. G and H, there's only one of those, B4. And then the probability of G is 2 out of 8, because remember our sample space had 8 options. G had B4 and B5, that's 2 out of the 8. H had 4 out of the 8. And then G and H, there was only 1 out of all of those. So if I simplify, 1 out of 4 equals 1 out of 4, yes, they are independent. How did I get 1 out of 4 on the right? I reduced by 2. How did I get it on the left? I multiplied by the reciprocal, canceled, and was able to get the same thing. All right, 2 more questions to go. In a particular college class, 60% of the students are women. 50% of all students in the class have long hair. 45% of the students are women and have long hair. Of the women students, 75% have long hair. Let W be the event that a student is a woman. Let L be the event that a student has long hair. One student is picked randomly. Are the events of being a woman and having long hair independent? So here are the questions that we need to work through. I wanted to know whether women and long hair are independent. And in order to do that, I need to calculate the probability of being a woman, given that they have long hair, and see if that's equal to the probability of being a woman. Or I could say long hair given woman, is that equal to the probability of long hair? Or I could say the probability of long hair and woman, is that equal to the probability of long hair times the probability of woman? Any of those work, but let's see what probabilities were given. The first one was that 60% of students are women, so probability of W is 0.6. 50% of all students have long hair, so probability of L is 0.5. So I am currently given this, and this, and this, and this. But then it says 45% of the students are women and have long hair, so I'm also given and. Of the women students, 75% have long hair, so that's a condition. Of the women students, 75% have long hair. That's the probability of L given W. So I'm given a lot of these, but I'm not given W given L, okay? So I can only use these 2. And I think the easiest is the multiplication. So is 0.45 equal to 0.5 times 0.6? It is not. This is 0.3. Those are not equal, so they are not independent. Okay. We toss 1 fair coin. The outcomes are heads and tails. There are 2 outcomes. We toss 1 fair die. The outcomes are 1, 2, 3, 4, 5, and 6. And there are 6 outcomes. If I multiply the 2 times 6, that means I have 12 total. Meaning if I roll a die and I flip a coin, there's 12 different outcomes. I can get heads with 1, 2, 3, 4, 5, and 6. And I can also get tails with 1, 2, 3, 4, 5, and 6, which is a total of 12 different options. If you flip 1 fair coin and follow it, toss with a fair-sided die, the answer in part C is the number of outcomes. What are the outcomes? We just set them. So let's say I have heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, then tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. If event A is heads on the coin followed by an even number, then we're looking at heads only and evens. So the outcomes are heads 2, heads 4, heads 6. And the probability is then 3 out of the 12 total. B is going to be heads on the coin followed by a 3 on the die. Well, heads followed by a 3, there's only one of those out of the 12 total outcomes. Are A and B mutually exclusive? Okay, well, do A and B share anything? Because if they do, then they're not mutually exclusive. Essentially, A and B probability has to be 0. If you look at A, H2, 4, and 6, none of that is in B. And if you look at B, H3, none of that is in A. Yes, they are. Are A and B independent? Mutually exclusive events typically are dependent because in order for them to be mutually exclusive, you have to know. But let's see. A and B is 0 equal to the probability of A times the probability of B. Is 3/12 times 1/12 0? Never. No. So that's going to be 1/48? No. So no, they are not independent. All right. Hopefully you enjoyed the exploration into independence and mutually exclusive events. We are going to move on to another round of probability questions now.